Two colleagues at the University of Manchester isolated graphene from graphite using a Scotch tape. Although theoretically scientists knew the existence of graphene, which is one atom thick, two-dimensional carbon crystal, no one worked out how to extract it from graphite. In 2010, two professors Andrei Geim and Kostya Novoselov got the Nobel Prize for Physics. Basically got Nobel Prize for using Scotch tape. Graphene has limitless potential. Graphene is the thinnest material with robust application. It conducts heat better than any other material, lighter than aluminum, elastic than metals, and harder than diamond. The properties of graphene make it unique in many ways. Graphene is an ultracapacitor. It has significantly more energy density, meaning it is able to hold hundreds of times more electrical charge compared to standard capacitors. Ultracapacitors like graphene are bigger capacitors that are inherently better energy storage devices that are able to store a larger amount of electrical charge than chemical batteries with quick charge-discharge rate. This property makes graphene ideal for new battery technologies with high capacity and less weight. Graphene batteries are currently used in electric cars for a fast charge intermediate between lithium-ion batteries and charging station. They are also used to recharge the battery pack on a force of a car brake because of their fast charging property. The other potential graphene batteries is to replace lithium-ion batteries completely with graphene-based batteries like graphene lithium, graphene silicon, or aluminum graphene batteries research. From these varieties of batteries, the most close to production is aluminum graphene battery. The Australian company Graphene Manufacturing Group GMG, which holds the patent for the development of graphene aluminum batteries, has already put out disc batteries to be tested in the real-world application. This graphene aluminum compared to lithium-ion batteries is 70 times fast chargeable, has 3 times more battery life, and it doesn't use any rare earth metals like cobalt, so it will make it cheaper. Among other uses of graphene, it is impermeable or highly liquid resistant, and even light element liquids like hydrogen and helium liquids cannot pass a graphene sheet. This makes ideal for water resistance in constructions and water distillation. The elasticity and conductivity of the material also make it ideal for flexible electronics of the future. For graphene application, but don't see it on our daily appliances. Why is the question? Current production methods of graphene are expensive as well as energy and resource intensive, and simply produce too little product, too slowly. Some companies do manufacture graphene and sell it for $60,000 to $200,000 per ton. There are a limited number of uses that make sense at these high costs. Current production can barely cover experimentation, much less widespread use. For a material that has been around since only 2004, a lot of progress has been made in scaling up the production and implementation of graphene. There are hints that graphene is starting to break through at a commercial level. There are a huge number of graphene-related startups looking at a wide range of uses ranging from energy storage to composites to nerve stimulation. Major companies such as Tesla, LG, and chemical giant BASF are also investigating how graphene could be used in rechargeable batteries, flexible or wearable electronics, and next-generation materials. Graphene is ripe for a breakthrough that will bring down the cost and increase the scale of production, and this is an area of intense academic research. One new technique discovered in 2020, called flash Joule heating, is especially promising. Researchers have shown that passing large amounts of electricity through any carbon source reorganizes the carbon-carbon bonds into a graphene structure. Using this process, it is possible to make many pounds of high-quality graphene for a relatively low cost out of any carbon-containing material like coal or even trash. A company called Universal Matter Incorporated is already commercializing the process. Once the cost of graphene comes down, the commercial applications will follow. The appetite for graphene is huge, but it is going to take some time before this material lives up to its potential. Thanks for watching. Please comment and subscribe for more tech videos.